This is section 721. We're going to take a look at the domain of a rational function. So we're going to find the domain of a rational function and interpret the domain to be a point of discontinuity or a vertical asymptote. Now, in its basic form, a rational function is just a function where you take one polynomial and divide it by another polynomial. So we have a polynomial on top and you have a polynomial on the bottom. Well, because we have a polynomial on the bottom, the domain of this function comes into play. And if you remember, when we divide, we don't want a 0 in the denominator. And so we're going to use that idea in this lesson. So if I wanted to find the domain of this function right here, all I have to do is just look at the denominator, say that it can't equal 0, and solve. So in this instance, x can't equal -1. And then the same thing here. Now, it's like, wait a minute, this 2. Well, that 2 doesn't have anything in the denominator, right? It's just 2 over 1. That's not a big issue. But again, this x plus 1, I can say that that can't equal 0, solve for it, and so x can't equal -1. Now, what does this actually look like? If I take this 2x minus 1 over x plus 1 and I put that into a graph, it looks something like this. Now, a few things to note here is we have this break in our function here. And that's at -1. Well, that happens to be where this where that domain restrictions seem to be, right? Because we, in the previous problem, we said, x can't equal -1, and here I have this break right there at x equals -1. And then there's another break. It seems to like break off here. And we're not going to talk about this just yet, but just know that that also has meaning as well, right? We're going to be able to find that out. And so that horizontal leveling off, we call that the horizontal asymptote. So we have both vertical and horizontal asymptotes, right? And we're going to talk about what that means. There's implications when it comes to the end behavior. Now, how do you find the vertical asymptote? So a vertical asymptote is one of the domain restrictions of a rational function. It's the value for x that makes the function undefined except 0 over 0. So if I were to plug this in and I were to try and find it, right, x plus 2 cannot equal 0, x minus 2 cannot equal 0, I get x cannot equal -2, x cannot equal 2. Those are going to be my two domain restrictions. But if I were to plug it back in, if I were to plug this -2 back in, right, you get -2 plus 2 over -2 plus 2. You get 0 over 0 times -4, so that's 0 over 0. Because this one gave me 0 over 0, that is not a vertical asymptote. So the only one that I would technically have is x equals 2. So that's actually my only other vertical asymptote. Now, it's a good idea to cancel it out. So if you do see that you're able to reduce it, you should reduce it, and then you get 1 over x minus 2, and it actually eliminates that 0 over 0 possibility. So example, if I wanted to find the vertical asymptotes here, I only have one right here, x cannot equal -1. For b, I can factor this into x plus 3, x plus 4, over this factors into x plus 4, x minus 4. Those cancel out, so I'm left with x plus 3 over x minus 4. So therefore, x cannot equal 4. Set it equal to 0, add 4 to both sides, x cannot equal 4. So this is my vertical asymptote. This is my vertical asymptote. And I know it's my vertical asymptote because it was a domain restriction, but it didn't give me 0 over 0. Right? That's the big one. Now, what does this 0 over 0 mean? So if you do get that indeterminate case, it represents a point of discontinuity. And another slang term for it is we call it a hole. Now, if you notice, if you look at this graph here, it doesn't appear like there's anything there. But if you were to look at the chart, at this -2, there's this value right here that it has like an instantaneous point that's discontinuous. And that's why we call it a point of discontinuity, or a hole, because it just represents this hole that exists on our graph. Now, you always get the hole if you get this 0 over 0. So, to categorize it, 0 over 0 is a hole. Everything else is a vertical asymptote. So, if I wanted to factor this, first times first is first, last times last is last, first times last is in the middle, isn't this a blast? The first sign's from the problem, seconds it's reverse, the last sign's always positive no matter what the first. And then on the bottom, this right here, that reduces, that's going to be my hole. So immediately I can say hole, x minus 2 can't equal 0, add 2, bam, there's my hole. Now everything else, which is this is my vertical asymptote. So x plus 2 cannot equal 0, x cannot equal negative 2. So there's my vertical asymptote. Let's look at B. I can factor out x. So you get x squared plus x plus 1. And on the bottom, I factor out x, and you get x squared plus 1. The x's cancel out. Okay, well, if I set x equal to 0, right, and so it's say can't equal to 0 and solve, that's my hole, because that's a factor that canceled out. Now, for my vertical asymptote, if I set this x squared plus 1 and try and solve it, I get imaginary. So there are no vertical asymptotes. So what did we learn today? We learned about vertical asymptotes and holes, and the way that you get them is by examining the domain of a rational function. So the domain of that rational function tells us if it's a vertical asymptote or a hole, or a point of discontinuity. What makes a point of discontinuity is if you look at the denominator and look at your domain restrictions and you get 0 over 0, everything else is going to be a vertical asymptote. So a vertical asymptote is a domain restriction that doesn't give you that 0 over 0 indeterminate case. This does conclude our lesson. If you have any other questions, please leave them in the comments.